multinational company and one of the largest oil and gas services companies globally. Starting as a field engineer in the production enhancement domain, he quickly scaled up the ranks and held multiple roles in engineering, operations, business development, and senior management. In 2015, Mr. Ajay was appointed the country manager for Halliburton, India's well intervention division, where he led a team of 140 employees with a business more than $25 million, and happened to be one of the youngest employees around the globe to have held that role. In 2016, he changed domain from operations to digital solutions consultancy and joined Halliburton Australia as a key account manager for East Coast Australia and New Zealand. He finally moved to the Middle East in 2018 and is presently managing digital sales for Halliburton, Northern Gulf countries such as Kuwait, Qatar, Jordan, and Lebanon. At present, he is stationed in Kuwait and delivering this talk from there. Now I request Mr. Ajay to start his session. Over to you, Ajay.
Thanks for the introduction, Professor. I will share my screen and will appreciate it if you can let me know if you can see it.
Yeah, it is there.
Excellent. Okay. So hello, everyone. Good morning, good afternoon, depending where you are. My name is Ajay Sharma, and I'll be doing my best today to give you some insights into the E&P, or as we call it, the exploration and production industry. And without wasting any more time, let's just jump right into it. So the next 40 minutes of your life, we're going to talk about an industry overview. We're going to talk about oil and gas industry as a whole, divided, subdivided, what things go on, what are the different domains. We will then talk about the connection that mechanical engineering would have or would apply, the set of skills that a mechanical engineer has would apply to the oil and gas industry. We'll talk about some pros and cons, because idea of today's session is not to sell you the oil and gas industry, but to show you what it is and then let you make a conscious decision that whether you want to chase at some point of time in your life. We'll talk about some statistics, and you'll see it when I show it to you. And we'll talk about market conditions. What is the existing market at this moment with the COVID pandemic situation going on? And I will try my best to share some tips that I think might help you land a job within the sector. So before we move on, quick points on why you should be listening to this webinar today. I have 10 plus years industry experience working on multiple projects in different countries. I've led a huge team of people with a lot of diversity of Indian and international people when I was back in India. So I've got a lot of experience managing teams. I've spent 2 years being a part of Halliburton's campus recruitment team or hiring team, and we have visited more than top 6 colleges within India. And I think this is one of the key metrics, right? It doesn't matter whether you're 20 or 30 years in the industry. You should have some experience of dealing with real life examples of recruitment, and that's when you can probably share the knowledge, as I'm trying to do today, and I'll try my best. And I've interviewed and interacted with, I would say, 2,500 plus undergrads, postgrads, and even working professionals, some of which we even hired. So getting right into it. The first thing that I would want to tell you, and I've seen a lot of non-technical people tell me this, but surprisingly, even some technical people having this impression. Disclaimer, this is not an oil well looks like. Definitely not. And today's whole intent is to show you, to let you visualize what some of the things look like, because as engineers, once we visualize things, I believe it seeps down really well, and then we start understanding that what kind of environment would the industry have. Because oil and gas is not something that we conventionally encounter within the workshops that we attend or the practicals that we do back in colleges, or even the industry intern experience that we have. So what you see on your screen, I would say, is the simplest representation of an oil and gas well. Right from the surface, it's a 3D isometric view. And what you have in there is essentially, we call it a borehole or a slim hole that we drill from the top of the Earth's surface. And as you can see, as you keep going down, there are these earth formations. the cap rock, the gas zone, and the oil zone. And it's a no-brainer to understand that in order for the hydrocarbons to flow back to the surface where you are, you will need some kind of a conduit or some kind of a connecting passage. And that's what an oil well is all about. It's basically a conduit that connects your surface all the way to your reservoir. Let me just open up my pointer over here so that I can show you a few things. So this is the depth of the well. Usually these depths could range from 3,000 feet all the way up till 18 to 20,000 feet below the Earth's surface. So it's pretty deep. And these holes that you see, which is a producing casing or a producer, these are usually 3.5 to 5.5 to 7.5 inches. So oil wells, if you look at it, if you try to visualize it, they're pretty slim. You can see some things like the cement overlap. That only means that once you drill a hole, you basically cover it with these telescopic looking conduits. These are nothing but cylindrical casing pipes, metallic pipes that are lowered into the Earth's surface, one section at a time to give your well more stability. And then it holds everything together. And when the hydrocarbons flow through within these pipes, they don't get contaminated. And you can probably get them in their crude form as they're supposed to be, instead of having a lot of contamination from mud and other formations on top of it. And this is, like I said, the most simplistic representation. There could be a gas zone and an oil zone even below that water zone. It could keep going on. So the depth of any well that you want to drill depends on where your hydrocarbon layers are and making that contact. Essentially, that's the gist of it. In terms of locations where you work on, let me just show you an instance. This picture was taken in the Permian Basin in the US, which is one of the highest oil producing basins in the world. And that we call this a land location because it's on land. And then, of course, you might have heard of this. This is offshore. This is somewhere in the North Sea. You can see a lot of these rigs and platforms. What you see in the picture basically is called a jack-up rig because it's jacked up on these three metallic pillars. And all of your operation, your days that you spend on field is going to be on this structure that you see right in the middle of nowhere. Now, you can see a lot of these in Mumbai High. ONGC has a lot of offshore rigs. You might have seen pictures, I'm not sure, but thought it would be always good to show you. So in terms of the industry division, we have three different, or I would say three most important divisions. And it's very important for you to understand this. If you don't understand anything else, this is the most important thing you would want to know, that there is an upstream division, which is essentially from the time that you start deciding that whether you want to drill a well in this place because there are hydrocarbons below, and I'll get to that in a second, all the way to producing it. Once you produce this, hydrocarbons come back to the surface. Now what? Now you need to transport them. So then comes the second stage, which we refer to as the midstream, which is transport and storage. You either store those hydrocarbons, transport them in pipelines, transport them in trucks, and make sure that they get finally delivered to the refineries, which then brings us to our downstream section, which is where all your crude, petroleum, hydrocarbons, gas are purified of any impurities. They're basically brought about in a commercially usable form, which could be gases in our regular households. It could be petrol, it could be diesel, or any other such fuels, even methane gas for that matter. Today's focus of our talk is going to be primarily on upstream, because upstream in itself is, as you would understand it, a petroleum engineer takes 4 years to even understand what the industries are. We will only talk about upstream today, and that's the industry that I belong to, which is the core exploration and production. And if you ask me, I think 80% of the engineering that you could think of as a mechanical engineer goes into upstream. I wouldn't downplay the midstream. There are a lot of opportunities over there as well, but I will let you guys to explore that section. Let's talk about E&P companies. So E&P stands for exploration and production. So you explore, basically you find where your oil and gas assets are, and then you produce out of it. These are some of the E&P companies. We also refer to them as client companies, because these are the people who own the assets. They buy these lands, and then they start their exploration activities. They drill wells. That's how they go about it. And Some of these companies are even Indian companies, or the companies which are in India right now. If you see Cairn, that's one of the best employers or the biggest companies within India. And they were recently, it was a British company, and they were recently bought by this mining company called Vedanta Group, which is pretty big. I have dealt with Cairn before as a client, and I would say that that is one of the best places you will get to work with. So it's not necessary that you definitely need to look for places out of India when you're looking for a job. There are some fantastic companies within India that give you that modern feel of everyday job and work life, and a tremendous work environment. Cairn is one of them, so that needs to be noted. On the other hand, these are the service providers. These are the companies that are consultant to these E&P companies, and they, by the way, do not own any assets. So I work for Halliburton that you see in the list. It's an American multinational. Schlumberger is, I would say, the biggest oil and gas service provider in the world. It's a France-based company. They're French, and they're in all around the world, right? So these are one of the two biggest, I would say, the top one and top two companies, Schlumberger and Halliburton. And then you have companies like Baker Hughes, Emerson. This is an interesting one. This company excels in automation. So this company's complete focus is into mechanical engineering, design of components, and a lot of automation. How do you integrate the electronic parts, create like a mechatronics division, and then get into that? So if you're into get that kind of thing, this is a company that will really interest you a lot. VRSPM is again into making iron and a lot of oil field equipment, and Weatherford again is a competitor to Baker Hughes, which is a consultant company. So when I say consultant, essentially what these companies say is, hey, E&P company, give us your asset. We will do everything right from exploration to your drilling, to your completions, to your oil production, and finally hand you over the oil output at the surface. And we will charge you a hefty fee for this. And obviously the operator companies being very stable financially, it makes more economic sense for them to outsource these jobs to these service providers. That's how the ecosystem works, because they cannot afford to have 10,000 more employees just to do the service company's job. They have got a lot on their plate already. I've tried my best to do the impossible, and I hope you guys can relate to it. At the end of it, I have tried to put together the whole upstream oil and gas in one slide. And let's go through it and then see if it makes any sense to you. So these are the 5 major phases of upstream oil and gas. And I'll get to each stage one at a time. So let's start with exploration. Exploration suggests that you acquire an asset or a land, but before acquiring it, you need to make sure that there are some reserves below it. How do we do that? Seismic surveys. Essentially, we are talking about doing a seismic survey, either a 2D or a 3D survey, wherein what you see on your left is a vibrator truck, which has a source right below it, and it emits these shock waves, or as we call it, seismic waves, down in the surface of the earth. Highly calibrated, fantastically engineered software and hardware these people have. And then there's another recorder truck that has these recording channels, which are also called geophones. And as you can see, the waves that transmit through the Earth's surface, when they hit a water or an oil reservoir or a gas reservoir, they refract with different indices. And that refraction causes a time delay for these waves to reach their respective geophones. And that delay in time is then calibrated against empirical relations, and then you decide what kind of formation do we have right below us. Is there only water in there, or is there oil, or is there any gas in there as well? And depending upon what you want to explore, then you check the financial viability as well of whether or not to explore. Now, how do we check it? These results that we get from these seismic surveys are then put into these extremely complicated engineering software, which not only analyze the patterns of different formations. By formations, I mean there could be sandstone, there could be carbonates, there could be shale, there could be dirty sand, sandy shale, all these different kind of formations or layers of different stones right below the earth. How are they layered? What kind of reserves are lying at what depth from the earth's surface? And then they start making these calculations that, is it going to be economically viable for me to explore this? What will be the cost of drilling a well? how much will it cost to get all the service companies paid? That means what will it finally cost me to produce 1 barrel of oil, and then they equate it that whether or not it's a good financial option or viable option to produce out of that zone. Once the field is finalized, then we come to our next phase, which is called a development, which is basically what you hear from the oil and gas industry: installation of an oil rig. Because what we need to do is we need to drill a well, we need to run some tests, which we have different tests like the drill string test or the injectivity test. Again, the only objective is to check the integrity of the well and the foundation and the formation, that whether it's good enough to give us those reserves. Because seismic surveys are accurate, but they are not super accurate. Obviously, it's just calibrated and modeled results. We need to practically see whether we're actually producing any oil and gas out of it. So that's where these oil rigs come in. They drill. When I say complete the well, after drilling, the protective pipe or the casing that you lower down the well so that you can produce out of it at a later stage is called completions. And these completions are put in place by cement. And cementing happens to be one of the divisions of upstream oil and gas. It's a very important division because you need to have a fantastic cement job. There's a tremendous amount of engineering that goes into each one of these aspects. So, which is why they have subdivided all of these into different domains. So you have a drilling domain, you have a cementing domain, you have mud engineering, you have completions, you have well interventions, you have hydraulic fracturing. Essentially, all these technical jargons just mean one thing, that the whole process, right from drilling with your bit, the first feet, all the way till you produce oil out of it, is an extremely complicated process, and it has to be subdivided. And if you join the industry, chances are that you will land in one of these domains, and you will stick to that domain either for the rest of your life or at least a good 10 to 15 years. So it's always advisable that whenever you get a chance, or if you get a chance, once the market stabilizes, you need to decide what domain interests you. Now, it's impossible to know how everything exactly works at this stage, but obviously we all are engineers. We can do our research, we can network with people, we can talk and see what part interests you the most. And I'll come to the domains in just a second. Finally, after everything is installed, we start producing. By producing, I mean the oil and gas reserves from the reservoir or cap rock formation brought all the way to the surface. Now, this phenomena looks complicated, but if you see the diagram, it's relatively simple. It works on the most simplest theory of Bernoulli's that we have learned while studying our engineering, and which is the differential pressure, right? We always know that a fluid is going to flow from a region of higher pressure to lower pressure. And in most cases, what you see right here, where you have your formation, there is some amount of pressure, obviously, because of these rocks have been squeezed down for generations by extremely heavy weights on top of them by the different other rock layer formations. And the oil and or gas, whatever hydrocarbons hides within the pockets of these rocks, they have a certain pressure. It could be 200 psi, 50 psi, or it could be 5,000 psi, depending upon where you're drilling. Needless to mention, if the pressure is too high, it's good for us, because then we can have this oil naturally produced. We call it naturally producing wells. These wells are mostly found in the Middle East, where their reservoir and formation are so rich that they need to do minimal effort for getting it back to the surface, and then start supplying it to refineries and then eventually to the end customers. Where you don't have that pressure, or if it's not sufficient, just to give you an instance, you drill additional set of wells which are called injectors. And I think it's very simple and evident if you look here. You start pumping water or gas or some other kind of fluid through these injectors that pushes that oil and gas along with a lot of other impurities back into your wellbore over here, which you have drilled, and then you start producing. These things, like I said, as you would reckon, 4,000 feet or 10,000 feet below the Earth's surface. And we are trying to make fluid calculations, volumetric calculations, heat and mass transfer calculations, temperature differential calculations, and frictional calculations, even the more important. What are going to be the frictional forces? What are going to be the pumping rates? All ties back to the fact that there's hardcore amount of mechanical engineering involved in all these processes. even the pumps for that matter, right? We have high pressure reciprocating pumps that do these jobs of pumping these fluids either into the well or out of the well. And these pumps are V8s, V12 engines, Detroits, Caterpillars, extreme amount of engineering going in a pump itself. And pump is a very small part of the ecosystem. We have batch mixers, we have rotating tanks, we have agitators. If you think about all these instruments, I didn't find a single thing that I could not relate it back to my curriculum when I was studying, right? So it's pretty exciting. The good part, it's cutting edge, right? So oil and gas has a lot of money and they make sure they make good use of it. Now, once the well has produced for the next, depends, 25 to 40 years, depending upon what kind of formation is it, because of local regulations and government laws, you need to abandon the well, or you need to make sure that it's shut off permanently, and that is the last phase in the upstream oil and gas life cycle. So what we do is we pump in cement or cement plugs, and that basically contains the flow of hydrocarbons if there is anything left, because mostly these wells are dried. You wouldn't want to abandon a well which is still producing unless there has been some major issue in the well at the bottom. And once we do this, the well is abandoned, we call it good, that's it. Few wells in every field would be abandoned. You'll see that few wells have already been abandoned for technical difficulties or lack of good production, etc. Because it's very costly to maintain a well and keep it running. There goes a lot of equipment, there goes a lot of manpower. So summarizing this slide, we have 5 stages in upstream oil and gas exploration where we decide whether or not to invest in that field or buy that land, whether or not there are going to be oil and gas reserves below it. Appraisal, where we investigate whether we have oil and gas volume based on the seismic results that we get, and then modeling them into extremely complicated software. These models are so complicated that, just to give you an instance, sometimes it takes like 36 hours to run one model simulation. That is the amount, and I'm talking about high-tech cloud computing kind of computers. It's extreme amount of tech. It takes a lot of resource. That should tell you the complexity of these models, of these, we call them grid modeling. As you can see, there's a reference image on the slide. And which is why the results are pretty trustworthy. But then we come to the development stage where we try to authenticate those results with physical example of hydrocarbons. When I say hydrocarbons, I mean either oil or gas or both reaching the surface. Once that is done and all the tests are done and injectivity is done, you kind of establish that, okay, this field looks good. Let's drill more wells. Let's start producing out of this formation, because now we have a lot of more information. One thing that I would like to point out, that when you're drilling a well and you're doing any kind of activities inside a well, one thing that you do is you run logs. We call it logging. Essentially, you run a radioactive source inside a tool, which when lowers down all the way in the well, it starts recording physical parameters of the rocks that it's passing by. So we make logs like gamma logs based on gamma ray recordings, density porosity, neutron porosity. All these things don't mean much to you at the point. I'm just trying to explain you that you get further evidence of exactly what rock are we dealing with over here and how do we make the best out of it. We move on to production. In its most simplistic terms, oil and gas reaching the surface, I refer to it as production, where you start extracting your oil or gas. And finally, once we are done with the well, we hit the abandonment stage where we abandon the well and then we move on. So what's the connection? If you look at the whole life cycle, I'll break it down the upstream in a different way now. We have geosciences, which and you'll come across these terms if you ever join oil and gas, and you'll be decided to join either one of the domains or being given an option. Geosciences is, in its most simplistic terms, it's study of your earth, which is, it has domains like geology, geophysics, geomechanics. So there's a lot of study of the earth involved. One part of it is understanding different kind of formations, heterogeneous, homogeneous, and correlating different factors. What are the different kind of rocks and everything. But then the other aspect of it is also geomechanics, where you start doing stress calculations on the rock. You need to know what are the hoop stress, what are the principal stresses, how do these 3 stresses act in 3 different axes what is the vertical overburden stress because of the weight of the earth itself. And then you start making these pinpoint precise calculations, which are utilized when you're drilling a well or you're carrying any kind of intervention activity in the well. The second part is reservoir. I would say this is a complete pure petroleum engineering domain, because you need to know a lot of properties of fluids of oil and gas, which we don't come across in our curriculum. I didn't find it very difficult to grasp it, because we do study fluid mechanics and a lot of concepts apply to the reservoir engineering side. So I know a lot of engineers personally who are great reservoir engineers. The geomechanics part, I've already explained it to you, how it works. Drilling and completions and production, along with a little bit of geomechanics. I think these are the primary domains that as a mechanical engineer, if you ever want to target the oil and gas industry, you should target. Because until geomechanics, it's just study. You're just studying, you're building models, you're doing seismic surveys, you're interpreting data that you're getting in, you're running AI on this kind of data, you're running machine learning on this kind of data. Once you get into the drilling and completions, that's where you physically move equipment to a rig site. And that's when you start drilling, and that's where all the fun begins, because now you're doing something that's tangible, that people can see and believe, and they have more faith on, which is actual production of oil and gas. And then all the way up till production, we have a lot of intervention activities and then abandonment. These are the domains that I would say I couldn't find one element in either of these domains that don't apply to mechanical engineers. I have listed down a few topics that you've studied that 100% apply to these domains. Fluid mechanics, heat and mass transfer, design of machinery, applied thermodynamics, strength of materials, mechatronics, even automobile for that matter, like I mentioned before, and all the way to the simplistic subjects like applied mechanics that you learn in your early semesters. Each and every element of these subjects apply in a very complicated fashion to the drilling and completions and production activities, and which is why you should be able to relate yourself to the field rather quickly should you get a chance or an opportunity to join. All right, so after this industry overview, I wanted to give you an insight into what working into oil and gas industry looks like based on my experience. Now, it could be completely biased, but I think I would represent a lot of people when I'm talking about these points and going over it. Let's talk about the bad first, right? Because I think the good far outweighs the bad and the ugly. One of the complaints that you'll hear people making is extensive working hours. We work round the clock. That's how I would like to put it. So when you start your career, 90% of the chances that you will start with a field job. That means going on field, getting down and dirty, getting your hands dirty, learning things right from scratch, and then moving up the ranks. Like I did, like 90% of the people that I know did. So when you're on field, the working hours are extensive. I have done 24-hour shifts. I have done 47-hour shifts, which sounds crazy, without sleeping. I've had like 4 hours of sleep for the next 25 days, continuously working on field. It's pretty demanding. Things are getting better now, but if you have less people on the field, you will always be taxed because you will be the engineer over there running the show. And if you don't have a replacement, you need to stretch. People complain about uneven work-life balance. Even after moving to an office job, I don't think that's a fair statement personally, because I think most of the jobs that we apply for these days are extremely demanding, and you need to give it all you've got. However, there is a good discipline in the oil and gas industry. Everybody respects your own private time. So yes, there could be a 24/7 working culture, or you could be sending emails at 9 p.m. in the evening. But if you have something urgent at 11 in the morning and need 3 hours off, I have not come across a person yet who didn't get that opportunity to do so without any questions raised, because we believe in getting the work done rather than staring at a watch and deciding how many hours have you put in for the day. A few reported health issues, you should know this. It's very infrequent, but they're obviously just like any other mechanical engineering site or a production line or a construction site where we work on. There are a few health incidents that have happened in terms of back injuries, finger injuries, but I think personally, my experience, I've never had an injury in the last 10 years, touch wood. So it really depends on how important you consider safety, because health, safety, and environment (HSC) is one of the biggest policies of all companies across the world. If an employee feels that there is a health or a safety hazard in doing anything, the company's CEO gives you the power and authority to stop that job and not let anybody do it unless the issue is resolved. So these companies are extremely serious about safety. They cannot afford a single cut or a scratch on your body. That's how serious they are about safety, right? So it all depends upon you. You need to take the onus. The ugly. Well, just throwing some fun within a serious talk. If you join the oil and gas industry, you might land up looking like this guy. Okay, goes to all Game of Thrones fan out there. The reason? You'll be staying extremely far from your families. You'll be in the middle of nowhere. For the most part, that picture on the right-hand side is not night's watch. That's an actual picture taken from a land rig in Canada. So if you're lucky enough to work in Canada, you'll be working at negative 40 degrees temperature Celsius outside, which I think is pretty crazy. Or you could be in the Middle East like I am. I'm no more in a field job. Obviously, I stopped going to the field a long time back, but Middle East temperatures soar between like 50 and 55. So, you could be working there when you start your career. And when I say ugly, I mean it. Look at this guy. So we're talking about arduous physical work in the first 1 to 4 years of your career. And that picture on the right, again, it's not fake. It's from a real employee. And at the end of every shift, you might land up looking like this if you're working in drilling or hydraulic fracturing or even Bayreuth for that matter. I have seen myself in the mirror like that for the good amount of, I would say, 1.5 to 2 years that I was on field, before which I was moved into an office role. But now, let's try to look at the good of it, right? What are the goods? If these are the challenges that exist, why do we even want to work in this industry? So I'll give you a few ones and then let you think. Money, obviously, very important to all of us these days, right? I think it shouldn't be, but it is a primary driving factor for all of us, because all of us want to succeed. All of us want to have good lives. All of us want to do good for our families who have worked so hard to put us where we are today, right? So I've given some figures, or I've collated some figures, being extremely transparent, right? So not being political about it. I'm going to show you some numbers that you could be making in India in the first few years of your career, all the way till 10 years. So good earning potential, this is what it looks like. In the first year, you could be making between 8 and 12 lakhs per annum. In the second year, or the third and the fifth year, you could be making 15 to 24. What's interesting is in year 6 and 10, as you can see, the growth is pretty exponential. You could be making 30 to 50 lakhs per annum, Indian rupee, right? And I think that's pretty competitive, being a work environment in India. I'm not aware of a lot of companies that pay this. I know of a few companies that pay even more than this, different sectors. So I'm not comparing them, but I'm just saying that this, if it's not great, it's definitely above average for Indian salary standards. And by the way, these numbers are extremely conservative that I've given you. You can easily add about, I would say, 30 to 40% on these in case you perform extraordinarily well or you are in the top league, right? You could be making much more than this that I'm showing you. If that at all serves as a motivation. Okay, the second part, this is my favorite, right? International exposure and reach. Before you know it, you'll be traveling to all different locations in the world for all different reasons. You could be traveling for your trainings, your on-the-job programs, on-the-job experience programs. We call it OJT, on-the-job trainings. You could be traveling for conferences, webinars as you keep proceeding in your career, and get to see a lot of different countries, a lot of different cultures, which to me is pretty exciting. I love traveling, right? So that was one of the best part of the jobs. The company takes good care of you. All your travel accommodation is being paid for, and they make you stay in one of the best hotels you could ever imagine, right? So these are not really important, but I think these small hits and bits that these companies offer really make the difference, right? Because that's what makes us feel good about ourselves. You feel valued. You feel that you're a part of a big company and that they're treating you well. I think that's really important, because employee satisfaction to me is the most important aspect of a company's success, right? You're only as successful as your employees are, they say. Frequent travel opportunities as well. sometimes to exotic locations, right? So just to give you an example, in the first 3 years of my career, I never flew international out of India before I joined this job, right? So I joined the job. In the second month, I was sent on training to Malaysia. I spent 6 months over there, and then in terms of frequent travel opportunities, I would say I presented a lot of technical papers, SPE papers in international conferences. I presented one in Abu Dhabi. I presented one in Brisbane in Australia. And when I say sometimes exotic, I had a paper presentation in Las Vegas. Yeah, that's right. You heard me right. I'm not joking. And it was a company paid trip to Las Vegas for presenting this technical paper, because apparently Las Vegas is the epitome of education. That's where all the technical papers are written and presented. Good perks and privileges and allowances, like I already mentioned, they take good care of you. Essentially, that's the bottom line. And finally, I would say that this industry definitely promises a strong career growth should you show the commitment of hard work and dedication in the initial years of your job, for sure, and then obviously going forth and going on. They have industry-leading training programs. I've been to some of the best training programs. The one I did in Malaysia for 6 months, it was a crash course for mechanical engineers to get into petroleum industry. And they taught us everything that I showed you before, right from your geosciences to your geomechanics to your reservoir to your production and all the way to your drilling. So within 6 months, I started speaking the lingo, right? I was aware of most of the technical terms. It was like a crash course, really taxing on you, like 8 to 10 hours lectures every day and then home assignments. But I think that really gave me a boost. And all of a sudden, instead of feeling like a stranger, I started feeling more related to this company and this industry as a whole. And finally, I would say the work is pretty entertaining and engaging as well, because what you do really stimulates your brain every day. There's a new challenge every day. It's not repetitive. It's not monotonous. And you get to meet a lot of new people, new clients, new locations. I think that's really exciting. And I think that's something that at least keeps me going on, keeps my brain stimulated, because I would hate to do the same job over and over again for the same company for the same time. All right, let's move on to some interesting stats as we come towards the end of the session. So job satisfaction factors. This was pretty interesting. I looked at this survey a few days back while I was preparing the slide deck. And if you can look at it, the few things that I talked about in my previous slide are the top 3 job satisfaction factors. Feeling of accomplishment, check. Technical challenges and technical knowledge imparting, check. Financial compensation, check. Also, the 2 downfalls that I mentioned about the industry, according to these people, control engineering, are not that weighted by the candidates when they apply for jobs. Now, obviously, this was just a survey. You might all have your own opinion. I'm just showing you what majority of the people think based on an online survey. And the third thing, now this was kind of a shocker to me, the things people least care about is work environment, travel, and company size. I don't completely agree with this. I think work environment really makes a difference. That's why all of us would never reject a job offer from Google or Facebook. Traveling, I don't know how many of you all get excited by traveling, but yeah, obviously it comes with a flip side that you sometimes have to stay away from your family and friends. If you work in a global company, you'll be always willing to travel, and you'll have to be ready to stay alone for good lengths of time. Company size, I don't agree with that, because I think if you're associated with a big name, it always gives you that pride and that feeling of satisfaction that you're making a change. All right, we talked about India numbers. Let's talk about United States, which is often used as a reference or a scale because it has one of the biggest job markets in the world, which seems to be attractive, and a lot of students want to go there, spends hundreds of thousands of dollars on their masters. So once you land a job in US, or once you do your master's course, these the blue lines obviously indicate the amount of dollars that you could be making, average annual salary, mind it. It could be higher or lower. And on the left hand side is the dollar scale, and you have a scale of projected percentage growth of jobs in these sectors in the year 2020 to 2022. basically a forecast of what number of jobs are going to increase in each of these sectors on a percentage basis, right, on a percentile. Have a look at this, where petroleum engineers stand, and that's mechanical engineers in the United States. We're talking about the same country, same economy, and similar kind of degree from similar universities, and that's the difference that you see right there. It was a little discouraging to me, obviously. I felt a pinch. I feel that a lot of times mechanical engineers are downplayed. I think it's one of the most challenging things to learn and fields of study because there are so many things in it that we study as engineers. But as the world is moving more towards automation, towards digital, I think sometimes mechanical engineering value is downplayed, but I still think it's the mother of all engineering. It's the strongest engineering that we can learn, because you get to learn a lot within your course as against some of the other engineering branches. Not downplaying them, but I would just say that I think the curriculum is pretty vast, right? We cover a lot of things when we learn. Finally, to conclude my session, before I go on to the job tips and tricks, this is the last thing about oil market. Not a pretty picture. This graph represents the prices of oil in dollars per barrel of oil. That's how we calculate it. It shows the trend in the last 25 years. And as you can see, there was a big boom that came up between the years 2002 to 2008. That was the era of the industrialization, right? That's when global economies opened up, a lot of trade started happening, companies moved from one country to another to promote their business. There are a lot of tax breaks and incentives that were given to these companies to get into these countries and improve the economy. And in the year 2008, it reached almost about $140 a barrel, if I'm saying that right. Yeah, 140. And then all of a sudden, it plunged and it came down to close to $40 a barrel. Now think about it. I'm just trying to explain you the industry dynamics. Say you're a business owner, right? And you're producing 1 million barrels of oil every day. That's, by the way, a lower side of production. Some companies make much higher than that. 1 million barrels of oil a day, 10 lakh barrels of oil a day. And oil is priced at $140. So you're basically making $140 million a day, right? And that's the income or the revenues that you're basing your company's profits and salaries and equipments and assets and capital values, liabilities, long-term, short-term debt notes, etc. And tomorrow, if I tell you, you wake up the next morning in a few months and you see that the prices today are $40 a barrel, what kind of shock that puts you in? Instead of making 140 million a day, now you're making $40 million a day. And that's just outrageous, right? So this industry is pretty dynamic. As you can see, there have been some few more blips and changes. This was the latest one in 2014 that the industry went down really, really bad. It tanked really bad. And then it came up again. And as you can see right now, the oil price is around in the mid 30s. And that's not a pretty sight. That's not a pretty picture for us people in oil and gas, right? So this era right here, between 2007 and 2014, we still used to call it the golden era of oil and gas, where there were the maximum number of jobs, really well paid. These days, I would admit, it's a bit of a struggle for most people in oil and gas. A lot of people have lost their jobs. However, I've got a strong feeling that these prices are basically just a hoax, right? It's because of the fact that the demand has all of a sudden declined because of the whole pandemic situation. And then obviously the oil trade wars that are going on between OPEC and Saudi Arabia and United States and Russia, that's contributing to this as well. I'm pretty sure they'll even out their differences once they start getting hit on their bottom line revenues. But what's most important is once the demand goes high enough, then the supply will still be limited. And that's when the oil prices will boom up again. And if you can see, it's a trend. It has gone all the way down over here and see where it surged up. So right now it's down. It cannot go further down. You see it's already surging up. It had gone all the way down to 20 and now it's become 37, right? That's almost like a 80% increase in just, I would say, less than a month, if you can see the graph. So the industry is definitely going to get better. So it just indicates that it's still a good sector to look at. It's not the best sector to look at because obviously I would not rank it the best, but it's definitely one among the best. Finally, my conclusion. I promise you I could take an hour talking about this topic because I think this is the most important part. But given the theme and the gist of today's presentation, I'll limit this to one slide and we'll finish at that. And I'll try to just summarize a few things that I think. 90% of these things you really know. I'll just try to give you a few pointers from my own, right? My first step is prep. Do prep, right? Whatever I've highlighted in bold, I think personally that these things are really downplayed. These are underplayed by a lot of people, right? When I say do your research, really do your research. Read about 100 companies, 100 different companies that you want to join. Understand your potential. See where you stand as an engineer. See what are your strengths and benefits. Networking, obviously, I would rank it at number one skill to get a job into any sector, right? You have to create a network. You have to reach out to people. You have to show them that you're brilliant, show them your confidence, and then move on from there. Because without referrals these days, it's very difficult to land anything. Shortlist, again, very important. A lot of people waste months and months of applying into jobs where they don't fit, they don't have the right experience, or they think that they can do it, but they cannot, they don't have the right capabilities. So shortlist something that fits you well, even if it's an entry-level position, and then start learning from there on, and then start making your way up. Because no company that you join, you're going to be an expert from day one, based on what you've learned in the college, right? So it's really important that you get down to the ground level, work it up, and then rise the ranks. I've tried to keep these points generic. All of these 100% apply to oil and gas, based on my experience that I've had interviewing for companies and interviewing for the company to hire people. But this applies to any field, right? So just take it as a quick tip from my side. Follow up regularly. This is one thing people miss a lot, because people submit applications, they send email bursts of their resumes, never follow up. Very bad habit. Your resume and cover letter. Just to give you an instance, when I made my first resume, I spent a week researching online how to nail the resume. And then I made my own without copying anything, without copying any formats or even the text or even the statements or sentences or even the skill sets. I wrote what I thought was right. I keep updating my resume. I still don't think it's perfect, because to me, a perfect resume is 1 page. And my resume is still 2 pages. And I keep trying to compress it down. I've made it 1.5 right now as I'm going forward, because resume, understand this, it's the first and the last impression that you're going to make on a guy who's going to read your profile before meeting you, right? Not every one of us have the luxury to meet you in person. Maybe you're great, but if you don't have a rock solid resume, extremely crisp, sharp, brief, only has things that you need to put in there. And let me just leave you with this note that every alphabet that you put in your resume needs to have an importance. Ask yourself, is this important? Do I want to write that I was I won a singing competition in my 5th grade, right? Unnecessary information. Don't do that. Keep only things limited to whatever is going to help you professionally, including, by the way, your co-curriculars and your extracurriculars. That's fine, but it needs to sound professional, right? Like leading a college captain team, or college team as a captain for cricket on a state level, that's impressive, right? Winning a cricket match in my 4th grade is not. So just be smart about it. And finally, execute. Get into the interview prep. Again, I think even a month is short for preparing for an interview. You need to study the company background. You need to know what kind of person you're dealing with. You have LinkedIn these days. You can go and research profiles. You need to know what kind of questions would be expected. Reach out to people within the same industry, ask, right? It never hurts asking. I don't think people put enough efforts in their interview prep and then they mess it up. Really good people I've seen, really capable people couldn't make it because they messed up their interviews. They weren't prepared enough, right? Learn how to handle pressure during an interview. A lot of people these days, they're stress interviews. They try to put a lot of stress on you, including us. See how to handle it. Keep your calm. Negotiations, again, sometimes people mess up negotiations. You need to know, and this is not maybe at an early stage, but at a later stage in your life, you need to know how to negotiate some of the things. And I don't just mean money. I mean everything, your work role, your profile, what are you going to do, maybe a training or two, etc. So learn those skills, how to do it in a polite fashion. Finally, my pro tip for the day, what do these Ivy League universities have in common? And the one thing that they have in common, which I think a lot of Indian industries lag or Indian universities lag, is the strength of their alumni committee, right? Their alumni committee reaches out for each other and helps each other out in any of the situations. And they have got such a strong alumni network that one guy, if he wants to land a job in any other sector, if he wants to move out or if he wants to progress to a higher position, it's always easy because there are seniors who have been in those industries like tens of different times, right? So I think every college should focus on a really strong and active alumni group where they're having regular sessions with the students, right? If not monthly, maybe once in 3 months, once in 6 months, depending, and really use the strength of the seniors who are at senior positions to pull up the next level batch, the peers, right? Because that's the whole idea. We always help each other. We always look out for each other. And I think that's really important. I would conclude my session giving a special thanks to RGID College, where I passed out of, fond memories back then. I would like to thank Dr. Sanjay Bukhare and Professor Kale for reaching out to me and arranging the session and giving me a chance to talk to you guys, and all the technical team members that made it happen. And I would also like to thank you audience for bearing with me for 50 minutes. Okay, I lied. It wasn't 40, it was 50. Thanks a lot, people. I will now open the session up for any questions.
Thank you, Ajay. Am I audible?
Yes, sir.
Thank you, Ajay. Your talk was very informative and explained everything, including operation part of oil industry, and of course the relevance of various subjects that is taught at the UG level, actually. The heat transfer, fluid mechanics, applied mechanics, you are told, advanced thermodynamics, and all these subjects. So the importance of those subjects taught at UG level. Then you told about the good, bad, and ugly part of the industry and the dynamics of oil industry, and that was very interesting. Actually, the slides and your explanation part was very interesting. You gave insights on job prospects for mechanical engineering students in oil and gas industry, and you spoke on necessary skill sets the graduates should have to start a career in this attractive field. Thank you very much, Ajay. Now, with your permission, I would like to invite questions from our participants.
Question
from a question answer session. Kajal.
Yes, sir. Go ahead.
Hello, Kajal. Do you? Hello.
Yeah, I can hear you.
Yes. I'm actually waiting for the technical team to put on some.
Yes, sir. We are doing it. Yes.
Sure thing.
Hello.
Hello.
Yeah.
Yes, sir.
Ajay, this is Sagar. Great session, Ajay. I have just one question. So how do you see the oil industry, the Indian oil industry, for next 5 years? I'm talking from point of view of a fresher. Suppose a fresher wants to get into this industry. How the industry will be for the next 5-10 years? Is it a good time?
Okay, to answer your question in short.
The Indian market I'm talking about.
Yeah, sure. So let's talk about the Indian market, right? So I think Indian market is doing really well compared to some of the other markets, because understand this, the integrity of an oil and gas company, I'll break it down in the most simplistic forms without getting complicated, right? How much money or how many dollars do you spend to produce 1 barrel of oil? Okay. And then what that oil barrel is sold at? Very simple math. So just to give you an example, some of the countries like Canada, where working conditions are so difficult, places like North Sea, where you're working in extremely dangerous situations. In order to compensate people there, in order to move equipment there, it's so expensive that these people make $1 of 1 barrel of oil for almost $50 to $55. Now, if oil is being sold at $37, you're dead meat, basically, right? You're losing money, you're bleeding revenue, bleeding profits month after month, until the market comes back to 55 or 60. So you have to cut costs, you have to fire people, you have to demobilize some equipment, stop doing some activities. In India, the cost of producing 1 barrel of oil, do you want to take a guess?
maybe 50%, seeing the population we have, the manpower we have.
Right. So you're saying 50%, like about $28, right? In India, cost of producing 1 barrel of oil, average I'm saying, across Karen or ONGC or Oil India, is about $7 a barrel, $7 to $8 a barrel. That is the total cost of producing 1 barrel of oil. You're selling oil at 37 right now, right? Yeah, you were selling oil at 100, 120 barrels at some point, right? But obviously gone are the golden days, and now you're at 37. Indian companies are still minting money left, right, and center for the most part, right? So India, I would say, is a very safe sector to join oil and gas at any point in time. I'm not saying that the industry pressure does not come onto India, because some of these companies are international companies, right? When they do have to do cuts, they don't differentiate between Houston office or India office, but for sure they keep in mind the fact that if India is doing great, let's not cut people. So I would say to join in the next 5 to 10 years. And Indian oil market has always been booming. It will be a good viable option. I would do it.
Thank you. Got that.
Hello, sir. Hemant here. Sir, thank you for the insights that you provided. So I have 2 questions. First one is, as electric era is approaching, so what according to you is the time duration until this oil industry will last in near future? To be specific, in automotive sector. And the second question is, what additional certifications and examinations will help in increasing the chances of selection in oil and gas industry?
Okay, great. Thank you, Iman, for your questions. I'll address it one by one. So, okay, great that you brought the electric question up. That's a question that we always get, right? So in terms of fossil fuels lasting within the Earth's surface, there have been a lot of disagreements on the internet. If you see, people are throwing stones at each other at the internet, right, for difference of opinions. But the most credible sources say that the hydrocarbons are going to stay for the next about 150 years, right, till what we can keep using them practically. And this is a safe estimate based on all the global estimates that are put together from different fields. Okay, so that's the amount of time. Because don't forget, once you extract over a period of decades, these formations start compressing and then they start forming oil and gas again, right? So there is a slow replenishment, but there is. When it comes to the electric industry, oh, I hate Tesla. No, I'm just kidding. I love Tesla. So I think, look, renewables, electric, solar energy, and all these things coming in, I think that's a really good thing, because it creates some kind of competition in the market. It relieves some of the pressure. And if you look at the pace at which they're expanding, it's not a threat to the oil and gas industry yet, because there is no way in the world that I would see in the next 70 to 80 years that these companies could completely displace oil and gas. Even when they claim they're completely electric, half of the cars are still hybrid. Like Tesla, BMW, Mercedes. Tesla is obviously a company which is completely electric, but if you look at BMW, if you look at Mercedes, if you look at Audi, Porsche, in fact, they came up with a new model Taycan. All these cars companies, they have at least 25 to 30 different car ranges, and these are the top players in the industry that we're talking about, and they have only one model that's completely electric, right? So I would say it is happening. That transition is happening. The market will be fragmented. There will be different players in the market of renewables, solar, and wind energy, nuclear energy, and even oil and gas. But I think in order for these sectors to match up to oil and gas, it will take at least 70 to 80 years. I don't see that happening before it, because the pace at which right now we are going, it's not going to happen very soon. Second question about your additional courses. I'll be very honest with you. I didn't do any additional courses. All the people that I've seen join, they haven't taken any single course from outside, because like I said, the industry trainings are cutting edge. We don't believe in people being 100% ready when they're from a different domain. The reason I'm hiring a mechanical engineer is not because I want you to solve reservoir equations. I want you to bring something new to the table from your perspective, from a mechanical engineering perspective, right? When you're on field and say a production job is going on and the petroleum engineer is making reservoir calculations, but you know what? The mechanical engineer see, hey, by the way, your pumping rate is low. We can still bring it up high because I've just calculated the coefficient of friction and it's still within the permissible limits. We can pump without reaching a kickoff point at the pumps. Just an example, right? So you need different set of skills. We hire mechanical engineers, we hire chemical engineers, and in a good quantity, by the way. The ratio is not 80-1. I would say the ratio is like pretty fairly distributed. I would say 40, 40, and 20, right? So you've got a tremendous scope. The only thing, if you want to take up a course outside, and that's my appeal to a lot of people, is think about personality development, think about public speaking, elocutions, and creating a good impression when you present yourself. Out of all the people that we interviewed in all these different colleges, the one thing that I felt that extremely brilliant students fell short on was communicating skills. And by the way, don't take me wrong, I just don't mean speaking English language, right? I mean non-verbal communication as well. Your body language, the way you speak, how you move your hands when you talk, shows your confidence, whether you look into the person's eye when you're speaking. And I would have loved to do a demo and a mock interview of this if I were to be in the college. But obviously we are limited by this pandemic situation. So I would just say, take up a course that sharpens your soft skills, because that's really important in MNCs like these for you to be extremely presentable, confident, because you're dealing with clients that pay us hundreds of thousands of dollars a day for doing jobs. We cannot send someone that is diffident or that doesn't have it in them. So I think that's really important. There is a famous saying in Hindi, we say, "Jo dikhta hai, wo bikta hai," and that applies in like 100% to oil and gas, right? So you got to be extremely presentable, except for being technically competent.
So thank you so much.
Good afternoon, sir. This is Vamsi. I'm in my final year. So the question I have is, like I had applied for Halliburton earlier, like I think last year. So I'm pretty much interested in the domain of operations and supply chain. So in this especially domain, the E&P domain in E&P companies. So what are the career opportunities for operations and supply chain industry?
Massive, to answer your question in one word. So we've got a massive supply chain department, because just to give you an example, we have tens of millions of dollars of inventory, and then logistics costs, transportation costs. We have heavy equipment that come in from outside. We have a lot of spare parts. We have a lot of actual equipment replacements that we sometimes need to air freight, sea freight on an urgent basis. We have tens of millions of dollars of inventory holding costs, if you look at it, right? And then we have, well, okay, oil and gas industry is not the best in terms of using Kanban or all these kind of systems that we use on production floors or JIT, but that is a very interesting topic you touched, because when I came in, I tried to apply some of those skill sets that I'd learned in my internship back in the days to oil and gas, to how to manage inventory properly, because inventory cost is one of the biggest costs that we look at. So supply chain manages inventory costs, supply chain manages logistics costs. How do we plan it in advance? How do we make sure we don't spend an additional dollar on things that we don't need to? It's an extremely important part. We have a full-fledged supply chain division, which has a procurement arm and a logistics arm, and there's definitely scope into it. You might have received a response or a cold response or a no response, factoring owing to this whole oil and gas crisis situation that's going on right now. But I would recommend that Halliburton is not the only company, right? Apply to, these days, the success factor ratio, if you ask me, you apply in 25 companies and maybe one company will respond back to you. That's how it goes. So I keep saying this to everyone, don't get demotivated by one company not approving it. There are tens of different companies that are into oil and gas, that have a supply chain branch and that are working in India. Do your research and look at them. There are new companies like Superior Energy. There is a company called NPS, which is a Saudi-based company which have started their arm in India. They're small in scale, but they're doing really well. See if you can crack into those companies first, because they have international presence in the Middle East and Asia Pac in a lot of different countries. So, if the top guns aren't replying, see what alternative you can find, and you will definitely land something.
Yes, sir. Also, last question. So, are there any specific requirements for this domain from a fresher, especially?
If you're getting into supply chain and logistics, I would say as a mechanical engineer, you're already overqualified, right? Because usually these domains don't require an engineering degree. However, I can tell you that I know one of the most smartest people in Halliburton that I've met who are very strong engineers and who are managing supply chain. They're like at regional levels and managing the whole regional supply chain. So I don't think there's any additional skill set that you need. One suggestion that I would give you from my experience, Halliburton's 100% of the workflows happen in SAP. So if you are an SAP champion, that will definitely make a big impact on your resume. See, that's what I mean by research. You asked me this question and I gave you this insight. You can ask somebody else a question in some other company. He can give you that insight. Reach them out on LinkedIn, send like a good striking message that takes their attention. Now, nobody can be a champion in SAP completely because all different companies have different T codes and different workflows of SAP. But even if you know the basics and the know-how and you put that on your resume that you've done some kind of an SAP course, that will definitely add 4 stars to your resume.
Thank you so much.
Yeah. Hello. Hello.
Sir.
Thank you very much, sir. Ajay, sir. It was a very
Pleasure.
nice question answer session. I think now, before we end this session, I request our Professor N.K. Deshmukh, sir, who is also alumni coordinator, to propose the vote of thanks. Over to you, Deshmukh, sir.
Hello, sir. I'm audible?
Yes, yes.
Thank you, Dr. Kalesis, our distinguished alumni of 2009 batch, and today's speaker, Mr. Ajay Sharma, respected principal, Dr. S.U. Bokade, vice principal, Dr. S.D. Deshmukh, sir, our beloved of the department, Dr. R.V. Kale, participants from all over India and abroad, from various fields, and my dear students. I deem it a great honor to propose the vote of thanks to all who have helped us in making this event such a resounding success. First of all, I would like to propose a hearty vote of thanks to our distinguished and respected alumni, Mr. Ajay Sharma, for taking his precious time and accepting invitation. I am grateful to Mr. Ajay Sharma for giving excellent coverage for various job opportunities for all engineering streams. Indeed, your words of experience and encouragement will definitely inspire our engineering students to seek a job in oil and gas sector. Thank you. Well, the event like this cannot happen overnight. The wheels starts rolling week ago. It requires planning and bird's eye for details. We have been fortunate enough to be backed by a team of very dynamic, motivated, and dedicated colleagues. So I take this opportunity to thank our organizing team members, technical team members, coordinators for their amazing work behind the curtain. I would like to express my profound gratitude to our RJIT management and principal, Dr. S.U. Bokade, sir, Vice Principal, Dr. S.D. Deshmukh, sir, for their constant guidance and support to this event. Without your support and encouragement, this event would not have been possible. Thank you very much, sir. I also extend my thanks to our head of the department, Dr. R.V. Kale, for his deep involvement in planning and detailing, support and guidance. Thank you very much, sir. I must mention my deep sense of appreciation to our wonderful students and participants who have turned up in such a great number and overwhelmingly participated. Finally, I again want to thank Mr. Ajay Sharma, our principal, Dr. S.U. Bokade, head of the department, Dr. R.V. Kale, all staff members, all participants, all HODs for gracing these events. We are going to conduct next webinar of this Alumni Speak series in coming week. Link of that will be sent to you on Telegram. Thanks to all. Have a nice day. Stay home, stay safe. Now I would like to request the host to end the webinar. Thank you.
Thanks all.
Yeah, thank you, Ajay. Thanks.
All right.